Hi, it's Mr. Taylor. Greetings, new students. I probably got to do some of this in class today, but if not, I wanted to capture it. Plus, I also kind of wanted to figure out how long this is going to take me to talk. I actually think the thing I'm going to do at the end, I could talk for a long time because that little survey I had you do at the start of class, there's a ton of information in there that's all related to what we're going to do for the rest of the year. So let's take a look at it. Before we do that, I want to back up for a second. I'm going to share my screen and hopefully I can do this right. I want to talk about the experiment we did in class, especially maybe if some people weren't there, so they can also learn what was going on. So we had this situation where, and I'm hoping you can see my screen now, where the setup was Joy supposedly could smell Alzheimer's, not Alzheimer's, always do that, Parkinson's. And so they did an experiment where they gave her 12 shirts. Some of them were worn by Parkinson's people, and some of them were people who did not have Parkinson's. And I don't know if the split was 6 or 6, but basically she went through, she smelled each shirt and said, yes, Parkinson's or no Parkinson's. And at the end, she had gotten 11 of those 12 guesses correct. So she identified, however many Parkinson's were, she did right, and however many non-Parkinson's she did right. And she, I think, identified one that she thought had Parkinson's, but they did not. So 11 out of 12 is her score. And our thought was, well, that's pretty unusual. It seems like maybe she can smell it, but could she maybe have done that purely by chance? And certainly the answer is yes. But what we want to do is get a sense of how likely that would be, or what sense can we put a number on that, because this is a math class. So what we did in class is we had everybody kind of simulate guessing whether it was Parkinson's or no Parkinson's. We could have flipped a coin. We did a little thing where one person was guessing whether another person was holding up a finger or not, but they did 12 guesses. And some of us got 6, some of us got 5, some of them got 8, some of us got 3, and we put those over together in a dot, and we had something that looks like what we have on the screen right now, except this was 100 sets of guesses, or what we'd call 100 simulations. This whole thing's got a simulation, but each dot is one simulation of someone guessing Parkinson's or no Parkinson's 12 times. So we don't know if Joy was guessing, but we know if someone was guessing, these are what the results might look like. And from this, you can say, oh, 11 was pretty unusual. And we can actually attach a number of that. It's 1 out of, in this case, 100. So there's a 1% chance of, in this, based on this simulation. If we did this again, and this is actual data that I ran, this is essentially valid, another 100 times, we might get no 11s. In fact, I could do this many, many, many times, and I would almost never get a 12. I will occasionally get an 11. Notice I also know how many 0s or 1s. It's just as hard to guess 0 right as it is to guess 12 right. So in this case, based on this simulation, there's a 0% chance that Joy could have done it purely by chance. So somewhere between 1% and 0% seems like a good guess based on those things. And then the interesting piece, the kicker, as we like to say, is there was a follow-up video where they said, oh, by the way, the one person that she misidentified, that person later was identified with Parkinson's. So she actually was 12 out of 12. So it seems pretty definitive, what we might say statistically significant, that she can do that. All right. So that's wrapping up the activity we did in class. What I probably started doing is, first of all, my email address and how you can get to my website, which probably doesn't matter if you've got access to Google Classroom, but I do that for students. I want to talk about this thing you filled out in class, and these are kind of some of my notes that hopefully you can see. Let me make this a little bit bigger in case it's hard to see on your screen. And I just want to talk about these things, and hopefully I'm not going to go on too long. So the first question was, do you have a pet? Easy enough answer. Probably you said yes or no, or some of you might have listed a number, but that didn't ask for a number. So my question is categorical or quantitative? Is the answer categorical or quantitative? And my guess is some of you would be able to guess, well, quantitative means it's a number answer, so it must be categorical, which it is. A yes, no answer, a thing that has essentially a word as an answer that's not numeric, is called categorical, or what sometimes is referred to as qualitative. So qualitative or categorical, that's like a yes, no, or what's your favorite color, or who's the best singer, or whatever. That's categorical, where something that has a numeric answer is usually quantitative. And I say usually because shoe size is that categorical or quantitative? We'll talk about that. Second one, how many brothers and sisters? Quantitative answer. I want to point out when you look at number 3, so for number 2, you're probably going to say 0, 1, 2, 3. Whereas number 3, there were several other answers you might have given. You might have said a little more than 3. You might have said 3.3 if you happen to know that. If you knew it to more decimal points, you might have said any of the answers I've got there. But there's a difference between these two. They're both quantitative, but one is what's called discrete, or you could even say it's got to have an integer answer. And the other is it's called continuous. Now, normally that means a decimal number, not all the time, but it normally means a decimal number. More precisely, it means I can be more and more refined with my measurement. I can do it to 1 decimal or 2 decimal or 3 decimals or 4 decimals. If I have an instrument that's sensitive enough, I can measure it to any thing I want to. So things like weight and height and certain other things are definitely quantitative for sure, but they happen to be continuous variables versus discrete variables. Very minor difference, but we have ways to describe these things. We have words for everything. Number 4. Now, I don't know how many people know how fast you run the 100 meters. I totally guessed. I said like 15 seconds. The question is, I intended this to be a quantitative question. Someone might have written very fast or very slow, or I don't know. This is potentially a categorical question. And the reason I point this out, if you ever happen to do a survey, you need to make sure that if you want a numeric answer, you force people to give you a numeric answer. Otherwise, you're going to have to look through all their weird answers, or if they like write 15.2 seconds, they add on that seconds, you're going to have to do what's called scrub your data and get rid of everything that's not a number. So definitely a quantitative, supposed to be a quantitative answer, could probably a continuous answer, because depending on how you're measuring it, you can do 15.2, 15.21, things like that. There's another thing I want to talk about here too, is bias. Is whenever you ask a question, you are potentially introducing bias in the answer. And what that means is that you are potentially causing people to answer it in one way or another. And there's other ways that you can introduce bias other than the way you ask questions, but bias is a big thing whenever we gather data, is have our methods of gathering the data in some way caused our answers to be too high or too low, or for more people to say yes versus no based on the way the question is worded or based on whom we ask, things like that. The fact that I said, how fast can you run? Fast might create some bias. Oh, I'm supposed to do this fast. I'm going to say 10 seconds. Good for you if you can run one in 10 seconds. Let's see. Okay. Number 5, do people who play a sport get better grades? Well, first of all, this is an opinion, but we could test it with an experiment. We could go out and find a whole bunch of people who play sports and not play sports and compare their grades and come up with some kind of answer that could at least be supported with that evidence. Depending on how we gathered that data, that might be a valid conclusion or not, at least for the set of people we're experimenting with. But I put it in there because this is the kind of question we do answer with experiments, and statistics and probability are very heavily involved in experiments. I think I have an alarm going off somewhere. No, that was one in the hallway. Okay, almost done. How many people at Oakland Tech? Pretend you are surveying students about their knowledge of Oakland Tech. I send out a survey. You send out a survey to all of them. You're asking this question of your peers. What's a possible problem to this question? Well, and my guess is this came up in class, and some of you probably asked me in class, do you mean people or do you mean students? It's a slightly different answer. I don't even know how many people are here this year, but usually it's about 2,000, and we have about another 100 teachers or so. And so could change. So maybe not the best question. My question is, okay, how many people, let's say total people, are at Oakland Tech today Is that categorical or is it quantitative? Little quiz. Hopefully you said quantitative. Is it continuous or discrete? It's a little harder. Discrete means basically I have a whole number answer, whereas continuous generally means it's probably a decimal answer. That's not there's some exceptions. If we averaged all the answers in the class, this is a follow-up question. So we took everybody's answer to class. Would it probably be better or worse than a randomly chosen answer? So I average everybody's, and then I go and grab one of yours at random. Is the average for everybody or the average for that one person likely to be better? And hopefully you're going to say, well, who knows who you got? It could have been somebody who said some crazy answer. In general, our average is going to be better because some people are going to guess high and some people can guess low. And usually when groups do these kind of things, their average tends to be towards the correct answer. Not always, and it also depends on how the question's worded, what kind of bias you created. Number 7, if the average for the 100-meter dash from question 4 for the students in this class is 15.2. So I averaged everybody, added them all up, divided by how many people are in the class. That's how we find an average, or what's called a mean sometimes. 15.2. Would it be reasonable to assume that the average for all students at Oakland Tech be close to 15.2? Now, this answer kind of depends. It's like, well, that's kind of reasonable. This class is probably representative of the whole student body, but then the question, well, is it? I tend to have juniors and seniors in my classes. Juniors and seniors tend to be larger and probably slightly faster than freshmen and sophomores. So maybe not. So in general, well, it might be close to 15.2, especially for juniors and seniors, but not necessarily. So this all really depends, but I would expect it not to be too far off, but I do think there's some bias within my class because of who's in my class. It's not necessarily what's called a representative body. And then I threw a word down here. You might notice I said I'd expect to be close. What does close mean? I would expect it to be within a few seconds of 15.2, even if it is skewed a bit lower because of the slow freshman. Now, skew means going towards one end or the other. We'll use that term a lot. Even if our class was a representative sample, I would think it would be unusual for it to be exactly 15.2. But I'd be somewhat surprised. In fact, I would be somewhat surprised if it was 15.1 to 15.3. I was like, oh, we were almost exactly right. So the point there is we can use a smaller sample to get a good estimate for a larger population, but there are some watch outs when we do that. Okay, last one. Study, and this is actually true. A study in the New York Times found a statistically significant increase in the amount of sleep between 2003 and 2016. There were 18 minutes more of sleep, I'm guessing for some number of adults. What does statistically significant mean in this context? Well, one thing it might mean is that it's very likely that we are getting more sleep. The fact that it's statistically significant saying, oh, we're getting more sleep. I'm not sure if it's 18 minutes more, but it seems like we're getting more sleep. Another way to say this might be the difference of 18 minutes is such a large difference that it's unlikely this difference is simply by chance. There's some variability. There is some variability there, but in general, because it's increased a lot, it's unlikely that it had to go up or down and it went up. Another way to say this, now this is really where we're getting very close to what the word statistically significant means. There is a less than 5% chance that this difference of 18 minutes could have been generated by chance alone. I'm getting very deep into things here, and for my AP students, eventually they're going to have to learn this wording very precisely. But the general idea is, statistically significant means what percentage, how likely or unlikely it is would this increase be purely by chance. And I've got one more note there. With a little more data, we might be able to say the chance of getting a difference of 18 minutes is 1 out of 50 chance. So we might even be able to say exactly, well, what percent chance? I know it's less than 5%. That's what statistically significant usually means. But I might be able to say exactly in the same way that I said with joy, there was a 1% chance, or there was a 0% chance, or a 0.002% chance is what I think it mathematically is. Okay, that's plenty. Thanks for your attention. And let me see if I can remember how to stop recording. How do I stop recording? Where is stop recording? Stop recording. Bye-bye.